Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 10, which is from the quadratic relations section.
That question. It says the path of a heavy object thrown into the air is modeled by this equation. So this equation is obviously quadratic. There's a squared and no other higher exponent. And it's given to me in standard form. Okay. So in this equation, h represents the height of the object above the ground, and d represents the horizontal distance that the object travels, both in meters. So before I actually even look at what I'm supposed to do with this relationship, I like to make sure that I understand it clearly. So there it is. That's the relationship I need to deal with. So a couple things. First of all, a is negative. And when a is negative, I know that I have a upside down parabola that looks like this. And again, that's generally what an object that's thrown into the air looks like. It goes up and then it comes down. So if I were to make kind of a quick little diagram to help me later on, so I'm measuring horizontal distance and I'm measuring vertical distance. So one is called d for distance and one is called h for height. And the next thing I like to do is I like to look over here because we know that this is an important value in standard form. This represents the starting position of, in this case, your height. So when d equals 0, right, that's where this graph starts, at d equals 0. And when d is 0, I can ignore this term and this term. So I know that I'm going to start at 0.8 meters. And then now I have a feel for what's going to happen. I'm going to throw the object, and it's going to come back down. So there's what this parabola looks like if I were to graph it. And again, I don't know any values except for this one, the 0.8 starting value, but I do know that it's a parabola and it's a negative shape and it's going to look like this. So now let's look at the actual questions we had to answer. So A says, from what height was the object thrown? Well, we know that, right? When the object is thrown is the start of this particular function. So the object is thrown right at this moment, or right, in this case, at the distance equals 0, because it hasn't traveled horizontally. That's when the object is thrown. And we've already discussed that it was 0.8 meters above the ground. So the answer for A was 0.8 meters. And there's no real math you have to show here. Your teacher should expect that you know that when you're given a standard form equation, the only information you instantly know is the shape of the parabola, in this case negative, and the starting position of your projectile or your object. And the starting position in this case is the vertical height is at 0.8. So there's my answer of part A. That was pretty easy. So let's look at the rest of the questions we have to deal with. So first of all, it says, how far does the object travel horizontally before it hits the ground? So this is why I like having this little meaningless sketch, because it's not that meaningless in the end. How far does it travel horizontally? So it's saying when I throw it, it travels in a horizontal direction. And at this point here, it hits the ground and stops moving. So to answer B, I want to know what this distance is. And how am I going to find that? Well, obviously this point here is a root. So I know that I have to get my roots for this particular relationship. So let's look at C. So one thing I'm going to have to do is find the roots. C says what was the maximum height. So maximum height means what is this height right here? And obviously that corresponds to vertex. So in this particular question, I need roots. Now I need both roots. So don't forget that there is an imaginary root over here somewhere that doesn't exist in the real world of this object, but does theoretically exist in the world of math for this equation. So I'm going to find both of my roots, one of which will be the answer to question B. And then I'm going to use my roots to help me find the vertex, right? Because there's an important relationship between the roots and where the vertex is. Okay, so that's enough pre-planning. Let's go do some math. Now, how are we going to do it? We know we need roots and vertex, and the fact is almost every question that deals with quadratic relationships is a question about roots and vertex. So let's review something that I mentioned in a couple of the other videos on quadratic relationships. So what I said was that the steps that you take to deal with your quadratic depend on the form that the quadratic is given to you in. So for example, if you're given a factored form quadratic, the easiest thing to do is find the roots. You can then use the roots to find the vertex, and you can also, if you want, find the y-intercept. This is in factored form. If you were given vertex form, you could very easily find the vertex. You could then find the y-intercept fairly easy. You could find the value of a to determine the shape. And that's good, but we weren't given vertex form. We were given, obviously, standard form. So the easiest thing to do in standard form is to find the y-intercept. Well, we did that already. That's what we did over here when we said, well, the y-intercept, or in this case, the h-intercept, is this constant value at 0.8. And then in the other videos, I said, other than that, standard form is kind of useless. And what you want to do is either factor it, if you can, or complete the square. But look at this equation. I really don't want to have to factor it. And even completing the square would be a nightmare. So I forgot that there is another thing you can do with standard form that is really, really important. I just, it slipped my mind because it wasn't useful before, but certainly in this question it's useful. So here's the other thing you can do in standard form. You can find the roots using the quadratic equation. And boy, I mean, as soon as I say that, you know how important a concept that is. So finding the roots is very important, and obviously we know we have to anyway. And that's the whole point of having the quadratic equation, is it lets us find the roots of a quadratic in standard form. So let's go do that. So again, here's my equation, and now I need to remember what the quadratic equation is. I'm sure you have this memorized. There is no way you can pretend that it's May and you haven't got this memorized. So I don't even want to talk about that. Of course it's memorized. So the value of A is negative 0.05. The value of B is 0.3. And the value of C is 0.8. So there's A, B, and C. And now it's just substitute and be good at math, right? So X equals negative B plus or minus the square root of B squared minus 4AC divided by 2A. Now you'll notice the way that I always do my substitutions is I start with just nice big empty brackets, and then I write stuff in those brackets. So B is 0.3. So negative B plus or minus square root of B squared. And then this is 4A. Oh, I think I need more room to write that. Sorry. Give myself a little more space. That's better. And then, of course, make sure this line and this line are long enough. So for A, C, all divided by 2A. Okay, so now you just follow the rules of math, particularly BEDMAS. So let's do that. So I have negative 0.3 plus or minus. Here's my square root sign. So 0.3 squared is 0.09. It's just 0.9, sorry. Whew. That was almost problematic. And I'll fix the square root sign while I'm at it. Okay, so in your calculator, 0.3 squared is 0.09. I was right. I knew I was right. Now, then I'm going to do negative 4 times negative 0.05 times 0.8. So first of all, a negative times a negative is going to make this a positive. And then again in my calculator, 4 times 0.05 times 0.8 gives me 0.16. And in the denominator, I have 2 times negative 0.05, so that's negative 0.1. Okay, so now keep going. I need to deal with this square root business because really a square root is like a bracket, and so according to the rules of BEDMAS, it's kind of going to take priority. So 0.09 plus 0.16 is 0.25. And then I'm going to square root 0.25. And when you square root 0.25, you get 0.5. Okay, so the only thing left to do is plus minus, and that's when you separate this into two different answers, one for the plus and one for the minus. So x equals negative 0.3 plus 0.5 divided by negative 0.1, and x equals negative 0.3 minus 0.5 divided by negative 0.1. So two pieces of math to do, and then we'll have our roots. So here, negative 0.3 plus 0.5 divided by negative 0.1 gives me negative 2. And here, negative 0.3 minus 0.5 divided by negative 0.1 gives me positive 8. So these are my roots. So let's go back to that diagram I drew. So remember, the imaginary one over here is at negative 2 because it represents going backwards. And in the reality of this question, we didn't throw backwards. But theoretically, we do have two roots. This one here represents going forwards. Okay, so did we answer B? Yes, we did. B said, how far does the object travel horizontally before it hits the ground? And again, looking at that diagram, we know that it started at 0 distance and it ended up at 8 distance. So therefore, we have the answer to B. B. It travels 8 meters horizontally. Good. So now we have to try to answer question C. And question C was we needed to find the maximum height. So we know anytime the word maximum or minimum is used, it's a question about vertex. So how do you find vertex? Again, let's go back to that little sketch I made. To find the vertex, you need your roots. So you take your roots, you find their midpoint, and that midpoint represents the axis of symmetry. And your vertex is always on your axis of symmetry. So let's go do that math. So the midpoint of the roots is negative 2 plus 8 divided by 2. 6 over 2 is 3. So therefore we know that the vertex is at 3 comma something. So all we have to do is take 3, sub it into the original equation, and we'll figure out what value is supposed to go here. Okay, so let's do that math. So we're going to be substituting in a value for D. And that value, again, was the midpoint of the roots, which is 3. Oh, dear. I must have been thinking about 3 anyway, because I accidentally tried to cube, which would have made a very big mistake. Okay, so now do this math in your calculator. So I'm going to, first of all, do that exponent. 3 times 3 is 9. Then I'm going to do those two little pieces of multiplication. Negative 0.05 times 9 is negative 0.45 plus 0.9 plus 0.8. So this gives me a maximum height of 1.25. And I'm assuming because the height is so small, that's why the original question told me that it was a heavy object, because it sure doesn't get very far off the ground. Maybe it's a anvil. Maybe it's Thor's hammer. No, because you couldn't throw that at all unless you were Thor, and then you could throw it a long way. Anyway, thanks for geeking out with me on that. So obviously the maximum height is 1.25 because your vertex would be 3, 1.25. So we're done. I hope that was helpful. Ask for help if you need it, and happy study.